Hello, welcome to the data channel and you are watching data modeling masterclass series. And as part of this today's video, we will discuss one more important topic in data modeling aspect, that is the purpose of three schema architecture. What is three schema architecture in data modeling, and what is the purpose of it? So that we will understand in detail with a particular example, in like a industry level example, and also what is external, conceptual, and internal schema, right? From the data modeling perspective, so that we will clearly understand in this particular video. So schemas actually serve as a framework for any like for organizing and understanding the data structure within the database information schema, right? And they provide a blueprint for how data is organized, stored, and accessed. So there are three main type of schemas that we see here: external, conceptual, and internal. So that we are going to discuss in detail. So before proceeding, if you are new to this channel, we would recommend you to please subscribe and also press bell button for instant notifications. So let's get started. So, like when we're talking about schemas in data modeling, so there are three different schemas that we are talking: external, conceptual, and internal, right? So external is nothing but it represents the way data is viewed and accessed by the end user or the application. So here the important point is end user or application, how they will see this data, right? See, the end of the day we are talking about the data, right? So how the data is seen from the different perspectives. So that is what the data modeling schema what we are talking about here, right? So here the external means it's the perspective of the end user or the application who is accessing it, right? And when you talk about conceptual, it provides a global view of the entire database structure without detailing implementation specifics such as storage mechanism or access paths. So here, so it is a conceptual path. It is like a architecture in the paper. It's a pen and paper, right? So you are defining, um, like you have a application, right? And for that application, before exactly implementing the database tables, you write ER diagrams, how each tables are conceptually and logically related to each other. So what exactly the relationship between them, right? And what are the constraints between them? So that is more of a like conceptual. And when you talk about internal, so it describes the physical storage structure and access method used for storage and retrieval of data within the database. So that's the difference. And now let us see the purpose of three schema architecture. So which is important to understand, right? So why what is the purpose of this that's three schema architecture? Why do we need to kind of think about these three as a different things, right? As a three different modeling, right? So, as you can see, the first thing is a different view for different users, because at each level there are different users, right? So this is achieved through the use of views in database. So suppose like you might be familiar with the views, right, in the database, which were created on top of the tables. Views allow users to see customized representation of the data without needing to alter the underlying data itself. So it is like you have an employee table or you have a customer table. So even though you have a customer table, so it can be viewed in differently for different customers. So the customer in like India location might be viewing the same data in different location, right? The products might be different for him. Okay, the customer who is from US, so the same data which is coming from the same table, like a products table, so the products table view might be different for that particular customer which is coming from the different location. So that's the different perspective that the same data is giving to the different users, right? And changing the next one is changing user requirements over time. The flexibility of the database design should allow for modification to accommodate evolving user needs, right? So this can involve altering existing views or creating new ones. Because so the as the requirement grows, or the because we are working in agile mode, the requirements for the views might change over the time. So what today might be a like at a conceptual model level, so tomorrow it might come to a user level, right? So that's the difference, right? So today what we are talking about, the conceptual model, the particular the constraints, right? So that might become an external schema tomorrow. So that is also the important point to note here, right? And the next is user shielded from internal details. So the other purpose is, so which is an important purpose, right? Because so user interacting with the database here through a logical or conceptual schema which hides the physical implementation of the details. Because see, as a customer who is like browsing in the shopping e-commerce site, so you do not know the physical implementation details of the particular e-commerce site, right? Of the product table or of the inventory table. So you do not know about that, right? And the details such as data compression, encryption, indexing. So those details are like nowhere concerned to the customer who is browsing that, right? So that is all shielded in that internal in the shielded from the customers here, right? So that we need to take care. And uniform data access. So uniform data access is regardless of the specific needs of the individual user. So they should all have access to the same underlying data. This is facilitated by the database DBMS, that is database providing various mechanism for data retrieval and manipulation. So what here we are saying is, so even though we are getting the different, giving the different perspective for different customers, right? So the underlying data, so underlying data will never change, right? So underlying data will always will remains the same, and that is been completely encapsulated or abstracted from the end user. And the next one is a flexibility for a database administrator, right? Should have a database administrator should have ability to modify the conceptual schema of the database without impacting how user interact with the data. So this typically achieved through the tools provided by the database management schema, right? Suppose if the DBA wants to like there is a one employee table or customer table, so he want to create a location table, right? So he should be able to go and create the location table and tag it with the customer table, right? Using the primary key and foreign key relationship and whatnot, right? So that's the relationship we can establish without disturbing the existing model. And the data independence. So this like changes to the physical storage aspect of the database, such as moving a different storage system or optimizing the internal structure of the table should not affect the logical or conceptual view of the data. So this is realized through the concept of the data independence, which separates the logical and physical aspects of the database. So these are basically these principle collectively contributes to the effectiveness, flexibility, and scalability of database system. So allowing it to adapt to the change requirement and technical advancements without disrupting the user's access or compromising on data integrity. See, like the end goal of the purpose of this three-tier architecture is to keep the things segregated as you go back, right? So external, conceptual, and internal, so they have their own boundaries. So we are setting the boundaries so that whenever you do the changes in the external layer, it will not impact the conceptual layer. So if and whenever you do a conceptual whenever you touch the conceptual model or the conceptual schema, it will not disturb external and internal. Basically we are drawing that thin line here, so that it will not disturb the other schemas when you are changing the particular schema, right? So that's the whole intent here. So now let's quickly jump to one of the important slide, so where we will understand where we will interestingly take a use case of a e-commerce platform case study like Amazon, for example, right? And let's understand how this three schema architecture looks like, right, at a very high level, so that it gives a glimpse of and it will be very easy to understand by this example, right? So let's take as shopping Amazon or any e-commerce, right, site, right? So when a customer visits the Amazon website or the app, they interact with the external schema, so they have their own customized user experience, right? So and the customer external schema might include features like browsing, right, products by category, searching for a specific item they are looking for, viewing products, say for example descriptions, images, reviews, so adding items to a shopping cart or completing a purchase. So this particular UI that they have designed, it is tightly coupled to a particular user, right? So it is not, it will be, so what this user is seeing in this particular UI is completely different from the other user what he is seeing, because it completely they have tailored it in that way, right? Because it based on the location, based on the whether it is a male, female who is shopping, right? Based on their history of the shopping. So all those will come into picture, right? So and past interaction with the platform. So they will have their own intuitive shopping experience, right? So this is actually a one layer, what we call it as a external schema, right? And now comes the conceptual schema. So the conceptual schema defines the logical structure of Amazon's e-commerce platform, away, abstracting away the implementation details. So here, just a um, logical representation of the logical schema, right? Here we are not actually implementing these tables in the physical database, right? And entities in the conceptual schema includes products, customer orders, vendors, inventories, all those tables, right? And attributes for each entity are defined such as product ID, customer name, order date, etc., etc., right? And so relationship between these entities, whether it is one to one, many to many, what kind of relations they hold, right, between each other. And constraints and rules are also enforced, such as ensuring a product have a unique identifier, order are associated with the valid customers, and inventory levels are updated correctly, right? So these are all the constraints. So we will it will be taught in this layer. So and this is the second layer of it, right? And the next layer is the internal schema, what we call, right, where it's a behind the scenes. Amazon database management system utilizes a internal schema to manage the physical schema and access the data. So internal schema includes maybe like details such as how product information and the customer data, order details, and the inventory records are stored in the backend servers, right? And techniques also used for the performance optimization, like indexing, caching, data sharding, maybe implementing at an internal schema level to optimize the performance and enhance the scalability. And also data security measures are also taken, because it is a heart of the data where exactly it's physically it is stored, right? It has to be protected very well. And such as encryptions and access controls are enforced at a internal schema level to protect the sensitive information. So the internal schema is hidden from the customers and sellers interacting with the platform, so who only see the external view. Because see, if you are a customer, so you cannot directly go and see what is there in this database, right? So you cannot you can see only what it is, what is what you want. I mean, from your perspective, what exactly you are looking for, or what is the interaction level that you have. Only that you can do. As a supplier, you have your own customized interface. Right? So you have your inventory management, you have your products, so only that specific details you can see. So that is how, see here, the main thing is a role based access control, right? So you need to know who is your customer, what is their role. So whether it is a customer, whether it is a seller, whether it is a um, third party vendor, whatever, right? So we need to be like maintaining all those levels. So that's how you segregate the three layers here. Okay. And in this particular example, the e-commerce platform schema demonstrate how external, conceptual, and internal schema work together to provide a seamless shopping experience for the customers, while maintaining the logical data model and efficient data management behind the scenes. So that's what we call it as the external schema, conceptual schema, and internal schema here. So hope this particular example was easy for you to make this topic digest, right, and understand. So now let's jump to the next topic and understand what exactly these particular. So now we have already seen the example of external, conceptual, and internal, how it looks like with the example. But in detail, theoretically, we will understand what is external, internal, and conceptual schema is actually about, right? So external schema is like objective of this is customization and user interface flexibility. So as we go through these details, right, you can relate to what we have discussed in this slide, right? So that it will be is very easy to understand and digest the topic. And the external schema represent the view of the database tailored to a specific need of a user, right? Or a group, or a user groups or applications. And it provides a personalized interface for a users, hiding the unnecessary details and presenting the data in a format that is intuitive and easy to work with that. And the main objective in the external schema includes allowing different users to have their personalized views of data, providing a user-friendly interface that matches the requirement of a specific application or a user group, and shielding the users from changing the underlying conceptual data in the internal schema, allowing for easier system evolution and maintenance. Because user need to have that restrictions, right? So external user um, who are actually just a customer, so should not have access directly to the database, right? So they should have access only to what they are intended to do, right? And the next is conceptual model. So in this conceptual model, as we can see, the objective is logical data independence, right? And the conceptual schema represents the logical structure of the entire database, right? Independent of any particular application or physical storage consideration. It provides a global view of the data model, defining entities, attributes, relationship, and constraints in a consistent and unified way. And this include providing a clear and comprehensive representation of the data structure and the semantics, ensuring that changes in the external schema or internal schema do not affect the conceptual schema, allowing for application portability and easier system evolution over the time. And also it facilitates the data integration and interoperability across different applications and systems. So lastly, we will see what is internal schema, right? So internal schema, the objective is physical data independence. In the previous, it was a logical data independence, right? Here it will be physical data independence. That means it's talking about the physical data, how exactly it's stored in the database. The internal schema describes how the data is physically stored, indexed, and accessed within the database management system. And it includes details such as storage structures, access path, indexing mechanism, and optimization techniques for efficient data storage and retrieval. So this object includes optimizing data storage and access for performance, scalability, and resource utilization, shielding users and applications from changing underlying physical data, allowing easier system tuning and adaptation to a new hardware or storage technologies. So as the technology and the project requirement evolve over the time, and also provides the data security integrity measures at a physical level such as encryption, access control, and the backup recovery processes, because here is where exactly the data is physically stored, right? And summarizing it, so overall the three schema that we have seen, the three schema architecture, that is external, conceptual, and internal architecture, that which we call it as a three schema architecture, is aimed to achieve data independence at a different level of abstraction, right? That means we don't want to mix up three different conceptual visualization or the conceptual modeling of the data, right? So that we have that flexibility to scale the database system, change over the time, and it will definitely help in maintainability, right? And and scalability in database design and management over the during the project life cycle. So hope this was useful, and thanks for watching.